Hey! Right. So question 8, the method of differences question. We're going to start with the first part, fairly standard kind of first part. Show that this is the same as that. So we need to put it over a common denominator. And normally when you're adding fractions, your common denominator is the product of the two denominators. So we're going to do r times r plus 1 as the bottom line of both of our fractions. So the first fraction we've had to multiply the bottom line by r, so we're going to multiply the top line by r. And the second fraction we've had to multiply the bottom line by r plus 1, so we're going to multiply the top line by r plus 1 as well, which gives us that, which is r squared minus, well what have we got here, it's difference of two squares, isn't it, r squared minus 1. I made a big thing about how easy it is to make mistakes with signs and multiplying out brackets when we talked about core 1 this morning. R squared minus r squared is 0, minus 1 gives us 1 on the top. And that's what they wanted, which is great. Hence, find an expression in terms of n for that. Now sometimes this throws people, because you see what's happened here, we've got that written, but there's no mention of r over r plus 1 or any of this, and there's not even a sigma appeared. So we've got to just check what there is going on here. What we've got here is what you get if you add up r over r plus 1, and the first term is when r equals 1. 1 times 1 plus 1 is 2. 2 times 3 is 6. 3 times 4 is 12, all the way up to n times n plus 1. So that sum there is the sum of 1 over r plus 1, as r goes from 1 up to n. And it's maybe worth just taking a moment to check that that is what we're looking at. Because every now and again we throw in a bit where it's a 2 in there, instead of it being just as far as n. Or we throw in a bit where we don't start at 1, we start at 2 or 3 or something else. And so you've got to just make sure it matches up. Now, hence, it did say hence, didn't it? And so the hence bit means that we've got to use what we've just done up here. And what we've done up here says that that series is the same as, so that series, the sum of 1 over r plus 1 as r goes from 1 to n, is the same as the sum of r over r plus 1 minus r minus 1 over r as r goes from 1 to n. That's the hence bit, so we're now going to do something with that. We're going to write out some terms and see what happens. We hope that they've given us lots of space to write this out so that we can make it really clear and take lots of space over it. If r equals 1, we get 1 over 1 plus 1 minus 1 minus 1 over 1. I'm going to write, I know it's 0, I'm going to write it there just for completeness so that I know that I've done it. If r equals 2, I am going to get 2 over 3 minus, now what would that be? 2 minus 1 is 1 over 2. I'm going to keep going because I want to keep going until I spot a consistent pattern and I know what I'm doing with this. If r equals 3 now, my third line, so I'm going to do r equals 3. 3 over 4 minus, what would that be? 2 over 3. Things are coming together. I think I know what I'm doing now. Look, I've got a plus half and a minus half, a plus 2/3 and a minus 2/3, a plus 3/4. Let's do one more. That's going to be, this is, what is this? R is 1, 2, 3, so it's 4 over 5 minus 3 over 4. And it would carry on. I've done enough to be convinced. You know, sometimes when you do these, you don't spot it until you've got 3 of them together, because you need things cancelling out a line apart. But this one is all worked out quite nicely. That with that, that's going to go with that. Plus 3/4 minus 3/4, blah, 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 all the way down. I want to do the last ones as well, just so that I've got them in there. And I think, because I've noticed that this is every 2 that matters here, I'll do the last 2, so that I've got them clearly in there. Now let's leave a little gap. The very last term is n in there, so that's n over n plus 1 minus n minus 1 over n. The term before that, so that's when r equals n minus 1, would be n minus 1 over n, and that would be n minus 2 over n minus 1. I've maybe even done more than I really needed to write down, but I would say that's probably about, maybe we didn't need that much, but that's kind of the minimum of what we want. Looking through this then, being careful to make sure that the person marking it can still read it really clearly, we've got that half goes out with that minus a half there. We've got that 2/3 minus 2/3, plus 3/4 minus 3/4, plus 4/5, there would be a minus 4/5 there, or there would have been a plus n minus 2 over n minus 1 there, so that can cancel out. Plus n minus 1 minus n minus 1 over n. There we are, I think that's everything, isn't it? Which leaves me with actually a remarkably simple one at the end. 0 plus n over n plus 1, sorry that that's come out red. I don't need to write the 0. There it is, that's all there is to it. N over n plus 1 was the sum of those terms. It wasn't a show, that question, was it? No. Hence find the sum as r goes from n plus 1 to infinity of 1 over r plus 1. Now these n plus 1 bits here, that just means that you go from the start up to where you want to get to, and then you take away the ones up to the point where this one begins. I didn't say that particularly clearly, but does it make sense? So when we talk about the sum from n plus 1 to infinity, of whatever it was, 1 over r plus 1, I think I want to recognise that that means the sum of 1 to infinity of my thing. I'm not going to write it because I can't remember. Take away, because that will go all the way from 1 up to infinity, so I need to get rid of the bits that I didn't want at the start, the first n terms that I'm missing out. Notice that we're only going up to the first n terms because we're starting at the one after that, which would be n plus 1. Right, so now we need to work out what these bits mean. Well, this bit, the sum from 1 to infinity, that is the limit as n approaches infinity of n over n plus 1. And I don't know how much detail we need to write about that, but that's what we need to think about. And that bit, the sum from 1 to n, is just n over n plus 1. We've already found that bit out. We've got that in the first part. Right, so this is the crucial thing. As n approaches infinity, what happens to n divided by n plus 1? I wouldn't say it gets close to 0, does it?
It's close to 1.
Close to 1, yeah. If you just think about it with a few numbers, infinity is pretty big. So let's start with things that we can manage. If it's 100, n is 100, well 100 over 101, that's just under 1, isn't it? It's not far off 1. If n is 1,000, 1,000 over 1,001 is even closer to 1. As we keep doing that, 1,000,000 over 1,000,001 is really very close to 1. And then we're nowhere near infinity yet. So the closer we get to infinity, the closer that gets to 1. So it's enough to say that that is 1 minus n over n plus 1. And that's our answer. Are we happy? And that's maths. Cheerful.